In the name of Almighty God, I'm Mahsa Hassan Koshi, and today I want to talk about design a simple calculator with 8051 microcontroller. The calculator we are going to design in this post is quite basic calculator. It will only perform four tasks, which are as follows. When you press the plus button, then it will add the two digits. For example, you want to add 2 and 3, then you need to press 2 plus 3 and equals these four buttons in sequence, and when you press the equals button, it will automatically will give you this result sum. For example, I press 2 plus 3 and you see the result as 5. When you press minus button, it will subtract the two digits like 3 minus 2 equals, and it will give you the result which is 1. So firstly I press the clear one, 3 minus 2 and equals to 1. When you press multiplier button, it will multiply the two digits. For example, again I clear the LCD, and for example 3 multiplier 2 equals to 6. When you press the divider button, it will simply divide the two digits. For example, I clear the LCD, and 4 divider to 2, and you see that the result is 2. Whenever you press the button equals, it will give you the output depending on the function you used before, and if you press equals in the start, then it will give you wrong input. Finally, there is on and clear button on the calculator. When you press this button, it will simply reset the code and will clear the LCD. So that's how this calculator is gonna work. Moreover, it will always reset when you try to calculate new values. So now let's design this calculator. So first we are gonna have a look at the Proteus simulation of simple calculator with 8051 microcontroller. After that we will do the coding part for calculator with 8051 microcontroller. So now let's get started with Proteus simulation. The Proteus simulation of this calculator with 8051 microcontroller is same as we used for interfacing of keypad with 8051 microcontroller, and is shown in this picture that you can see. So you can see we have used the same LCD, which is 20 multiplier 4, and have used the same keypad as did in previous project. You can see the keypad has all the required operations for this project, which are plus, minus, multiplier, and divider. Now let's have a look at the programming code for calculator with 8051 microcontroller. Introduction to 8051 microcontroller. 8051 is one of the first and most popular microcontroller, also known as MCS 51. Intel introduced in the year 1981. Initially, it came out as an N-type metal oxide semiconductor, or NMOS based microcontroller, but later versions were based on complementary metal oxide semiconductor or CMOS technology. These microcontrollers were named ATC51, where C in the name tells that this is based on CMOS technology. It is an 8-bit microcontroller, which means the data bus is 8-bit. Therefore, it can process 8-bit at a time. It is used in a wide variety of embedded systems like robotics, remote controllers, and automotive industry, telecommunication application, and power tools. System on a chip. It is referred to as a system on a chip, or SOS, SoC microcontroller because it is a chip circuit, integrated circuit that holds many components of a computer together on a single chip. These components include a CPU memory, input-output ports or I/O ports, timers, and secondary storage. And what is the features of 8051 microcontroller? There are some key features of 8051 that works as a foundation for students to learn microcontrollers. 8051 Micro C family member. 8051 Micro C have some family members. 8052 microcontroller and also 8031 microcontroller. 8052 microcontroller has 8 kilobytes of on-chip program ROM instead of 4K bytes and 128 bytes of RAM. An 8031 Micro C has 0k bytes of on-chip program ROM and 128 bytes of RAM. And what is the block diagram of 8051 Micro C? The first one is oscillator and timing. Oscillator, this circuit provides the microcontroller with a clock signal. All of the microcontroller's actions are synchronized by means of the clock signal. And what is this timing? In order to control the timing of activities within the microcontroller and guarantee that each instruction is performed at the appropriate moment, the timing circuit collaborates with the oscillator. And the second one is a 4096 byte program memory. Program memory or ROM, the program code is kept in this type of non-volatile memory. Typically, the on-chip ROM of an 8051 microcontroller is 4KB or 4096 bytes. The third one is 128-byte RAM. While the microcontroller is in operation, temporary data is stored in random access memory or RAM of a form of volatile memory. The 8051 has 128 bytes of inbuilt RAM. The fourth one is two 6-bit timers. Timer 0 and timer 1 are the two 16-bit timers on the 8051. These clocks may be used for counting events, monitoring time intervals, and creating time delays, and also among other things. The fifth one is a 64-byte bus expansion control. The microcontroller may interact with external memory or peripherals thanks to bus expansion control. It facilitates the extension of control signals for external devices and the accessible memory area. The sixth one is programmable I/O. Programmable input-output ports. The four I/O ports, ports 0 to 3 of the 8051 microcontroller may be configured to carry out a range of input and output operations. And the seventh one, the programmable serial port. Serial port or UART serial communication is made possible via the universal asynchronous receiver transmitter. It can send and receive data concurrently while operation in full duplex mode. The synchronous shifter. Data is shifted in and out of the microcontroller in synchrony using a synchronous shifter. It is frequently employed in communication protocol when exact time is necessary. And the final is 8051 CPU, Central Processing Unit or CPU. The microcontroller central processing unit is responsible for carrying out instruction read from program memory. It controls the other parts, handles data flow inside the microcontroller, and executes arithmetic and logic operations. Together, these parts provide the 8051 microcontroller its versatility and strength as an embedded system application. Introduction to 8051 microcontroller. FT8051 is one of the first and most popular microcontroller, also known as MCS51. And now I wanna talk about the application. Application of 8051 microcontroller. The first one is automation. The 8051 microcontroller is widely used in automotive applications. They are widely used in hybrid vehicles to control engine options. In addition, functions such as cruise control and anti-brake mechanisms have been further enhanced thanks to the integration of microcontroller and also medical devices. Convenient medical devices such as blood glucose and blood pressure monitors contain microcontrollers that display measurements. The next one is energy management. Competent measurement systems support energy consumption calculations in home and industrial environment. These measuring systems are prepared by integrating a microcontroller. And the next one is touch screen. Many microcontroller vendors incorporate touch functionality into their design. Portable devices such as media players and gaming devices. Use of 8051 microcontroller. Here are some of the most common use of the 8051 microcontroller. The first one is embedded system. The 8051 microcontroller is commonly used in embedded systems such as home automation systems, security systems, and industrial control systems. Its low cost, small size, and ease of programming make it an ideal choice for this application. Automotive systems. The 8051 microcontroller is used in automotive systems such as engine control units, anti-lock braking systems, and airbag systems to control various functions and ensure safe and efficient operation. The next one is robotics. The 8051 microcontroller is used in robotics application to control the movement and operation of robots. It is commonly used to control the motor, sensors, and other peripherals of the robots. The next one is consumer electronics. The 8051 microcontroller is used in a variety of consumer electronics products such as digital cameras, gaming systems, and audio players. It is commonly used to control the user interface, display, and other peripheral of these devices. The next one is communication systems. The 8051 microcontroller is used in communication systems such as modems, routers, and switches to control the data transfer and communication protocol. The next one is medical devices. The 8051 microcontroller is used in medical devices such as insulin pumps, heart monitors, and blood glucose meters to control various functions and provides accurate and reliable results. The next one is industrial control systems. The 8051 microcontroller is used in industrial control systems such as process control systems and manufacturing equipment to control and monitor various processes and operations. And what is the issues in 8051 microcontroller? Here are some of the common issues in the 8051 microcontroller. The first one is limited memory. The 8051 microcontroller has limited program memory and data memory. The program memory is typically 4 KB or 8 KB, and the data memory is typically 128 bytes or 256 bytes. This limitation can be an issue when developing complex applications that require more memory. The next one is limited processing power. The 8051 microcontroller has limited processing power compared to modern microcontrollers. Its clock speed is typically between 12 MHz and 24 MHz, and its instruction set is limited. This limitation can be an issue when developing complex applications that require high processing power. The next one is limited peripheral support. The 8051 microcontroller has limited support for peripheral compared to modern microcontrollers. It has a limited number of input-output pins and its communication interfaces are limited. This limitation can be an issue when developing applications that require a large number of peripherals. The next one is limited development tools. The development tools for the 8051 microcontroller are limited compared to modern microcontrollers. The available compilers, debuggers, and simulators are not as advanced as those available for modern microcontrollers. This limitation can be an issue when developing complex applications that require advanced development tools. The next one is limited security features. The 8051 microcontroller has limited security features compared to modern microcontrollers. It doesn't have hardware security features such as memory protection and encryption, which can be issue in applications that require high security. And eventually, the conclusion, an extremely reliable and flexible part that is frequently utilized in embedded system is the 8051 microcontroller. Its extensive design consists of 128 bytes of RAM for short-term data storage, 4096 bytes of program memory for code storage, and an oscillator and timing circuit for synchronization. For accurate time management and event counting, two 60-bit timers are included, and a 64-byte bus extension control makes it easier to connect to additional peripherals and memory. The programmable serial port, which its full duplex UART guarantees effective serial connection, while the programmable I/O ports provide versatility in integrating with different devices. The synchronous shifter improves data transfer operations precision. The CPU of the 8051 microcontroller is at its core. It coordinates the action of these parts to effectively carry out complicated commands. The 8051 microcontroller is a great option for a variety of applications, ranging from a straightforward embedded project to intricate industrial automation systems. Thanks to these qualities, comprehending every component of the 8051 block diagram offers valuable understanding of its operation and potential, enabling designers to successfully utilize its capabilities in their design. Thank you for your watching until the end.